Hi, sixth grade accelerated students. I hope everyone's doing well. Hope you're having a great week. This recording is supposed to be for Wednesday, the 21st. So obviously you can watch it whenever it is most convenient for you. But on Monday, you guys are taking the quiz. And then on Tuesday, let's see, I forget what your schedule is this week, but let's see. On Monday, you are taking you're looking at evaluating algebraic expressions, and then Tuesday, you're taking the mid-module quiz, right? And so then I wanted to talk to you about Wednesday, Thursday, and Friday's work. So let me bring up just a few problems. You guys are looking at properties this week. So commutative property, distributive property, associative property, and identity property. So those are the properties that we're looking at for Wednesday. All right, so if you guys were driving to work, well, first of all, if you were riding with someone to work, you will be driving soon enough, I promise you. But if you were riding with someone to work, I've lost my mouse, here we go. Then you are commuting, right? To commute means to move. So from your house to work or to school every day, you're commuting, you're moving. So basically that's what commutative means. If you take two numbers and you either add or multiply them, but then let's say you change their order. I'm having a hard time with my mouse, you guys. If you change the order for multiplying and dividing, it doesn't change the answer. So for example, the first one, if I add 3 and 4 together, I get 7. Well, if I move the order, if I change the order of those numbers and add them, I'm still going to get 7. 3 plus 4 is 7, and 4 plus 3 is 7. So you can do that with multiplication and addition. You can change the order that you multiply in or add in, and you're going to get the same answer, okay? Now, there's not a commutative property of division or subtraction. It doesn't exist, because if I say 6 minus 1 and get 5, but if I change the order to 1 minus 6, that does not equal 5. Okay, same thing with division. If I change the order of numbers that I divide, I'm going to get two different answers. So this property is just for addition and multiplication. I can change the order and get what I had originally. Now, this one looks a little bit more complicated. So this is a factor of, so we're multiplying 3 times the quantity of 4a minus 2. So if I'm going to change the order, I got to keep this whole quantity together. I'm going to change the order. I'm going to bring that whole part to the front, and I'm going to send my times 3 to the back. So be careful, that one's a little tricky. So when you're identifying properties and you have a problem like this one you might be a little confused on this, but basically it's keeping your factors the same, but you're changing their order, okay? So on the last one, that we're finding the factor of 3, or the product of 3 and 4a minus 2. So you got to keep 4a minus 2 together, bring it to the front, and multiply it by 3. All right, so what about distributive property? So distributive property, so for order of operations tells us to do what's in the parentheses first. So the first thing, if it didn't tell me to use the distributive property, the first thing I would do is add 3 plus 5 and get 8. And 8 times 2 is 16, right? But if it tells me to use the property, the distributive property, I'm going to distribute the 2 to both numbers in the parentheses. I'm going to multiply 2 times 3 and 2 times 5. So we already know the answer is 18, right? Because we know 3 plus 5 is 8, and 8 times 2 is 16. Where did I get 18, you guys? Oh my goodness. Just kidding. It's 16, because 3 plus 5 is 8, and 8 times 2 is 16. All right, so we already know the answer. But anyway, let's use the distributive property. So 2 times 3 is 6, plus 2 times 5 is 10, And now we're gonna add 6 plus 10 and get 16. So we know that's right because we already knew the answer, right? All right, let's do the subtraction, distributive property with subtraction. So first of all, if we weren't using the distributive property, we could subtract 3 minus 2 and get 1. And then 2 times 1 is 2. But let's use the distributive property. Let's say, what's 2 times 3? 2 times 3 is 6. And then don't forget to distribute it to the second number. So this is saying minus 6 minus 2 times 2 is 4. And 6 minus 4 is 2. So we know that's right. Now the reason we use the distributive property is because when we have numbers in the parentheses that are unlike terms, we literally can't add them together. We're not allowed to add unlike terms. So to solve this problem, to simplify it, we have to use the distributive property. So we're going to multiply 2 times a. Well, 2 times a is 2a. And 2 times 6 is 12. And those are unlike terms, so we can't go any further. We can't add 2 and 12 because they're unlike each other. They're unlike terms. So that's the final answer. So using the distributive property is the only way we can simplify that expression because we literally can't add together 6 and a. All right, same thing. If we have 2 times a, we get 2a. And then minus, I see a minus on the inside, minus 2 times 6 is 12. Once again, that's as far as we can go because those are unlike terms. And we're done. 2a minus 12 is simplified. All right, so look at the bottom one. Write an equivalent expression for 8x plus 18. So I'm kind of thinking of it as the distributive property. What could I distribute to whatever's in the parentheses to get this expression? Well, one thing I can do is think, okay, what could I divide 8x and 18 by? What is a common factor? Well, they're both odd, so couldn't I divide them both by 2? I could. So I'm thinking of pulling out or dividing by the a common factor. So, you know, I know 8 can be divided by 4, but 4 won't go into 18, right? I could divide 8 by 8, but can I divide 18 by 8? Nope. So 2 is the greatest common factor. So I'm going to pull out a 2. I'm going to think, what's 8x minus 2? Not minus, excuse me, 8x divided by 2, and that's 4x. What's 18 divided by 2? It'd be 9, right? All right, so are those two equivalent? Is this equal to this? Well, in order to check, I could use the distributive property. So 2 times 4x is 8x, and 2 times 9 is 18. So by using the distributive property, I can check myself. Yes, they are equivalent. So this and this those are equivalent expressions, okay? All right, let's move on. Now, associative property, your associates are kind of like the people you hang out with, right? You associate with your group of friends. So associative property of addition and multiplication just simply means you change the order. You're changing your group, not your order, excuse me. You're changing your grouping. So for example, let's look at the first one. Now notice for both of these addition problems, the order of the numbers have not changed at all. The order of the numbers have not changed. Even with these multiplication problems, the order of the numbers is not changing. The only thing that's changing is the grouping. Your associates are the group that you hang out with, right? So order of operations tells us to add our parentheses first. So 3 plus 4 is 7, and 5 plus 7 is 12. All right, same number, same order, but now we're going to add, we changed our grouping. What are we going to do first now? We're going to add 5 and 3 and get 8, and 8 plus 4 is 12. So even though I changed the grouping, I got the same answer. Well, that's true with multiplication as well. This parentheses tells me to multiply 3 times 4 first, and I get 12. And then 12 times 5 is 60. Well, the next problem tells me to multiply 5 and 3 first, changing the grouping, not the order, and I get 15 times 4. Well, guess what 15 times 4 is? It's 60. So the associative property tells me I can change my grouping of addition and multiplication problems, and I'm going to get the same answer. Now, identity property, think of it kind of as a mirror. When you look in a mirror, what do you see? You see yourself. You see what you started with, right? Who was that person that got out of bed that morning? Well, if I look in the mirror, I'm going to see that person, myself. So in order to get what you start with, so if I start with 8 and I want to add something to 8, but end up with 8, well, that means I have to add 0. So 8 plus 0 is 8. 5 plus 0 is 5. 10 plus 0 is 10, right? You get what you start with. Well, what do I multiply by to get what I start with? Well, if you multiply any number times 1, you get what you start with, right? So 8 times 1 is 8. 5 times 1 is 5. 10 times 1 is 10. So when we're talking about the identity property, for multiplication, that means that you're multiplying by 1. And for addition, that means you're adding 0, because you want what you started with. That makes sense? Identity property, you're either adding 0 or multiplying by 1. All right, so next, we're going to start looking at identifying like terms. So to make two terms like each other, there's a couple of things that have to match. They either have to be constants, which means it's just a number with no variable. All constants are like terms. Or if you have a variable, the two variables have to match and the exponent for those variables have to match, okay? So for example, I see a variable of a, well, I don't see an exponent, which technically means the exponent is 1. If I don't see an exponent, it means it's 1. So 5 to the first power is 5. 6 to the first power is 6. If I don't see an exponent, it's a 1. So 4a to the first power, or just 4a, is like, what else? What is like 4a? Well, x and a are not the same variable, but look at 6a. 6a to the first power. And look at the last term. I see an a, but look at the exponent. They're different. So 4a squared is not like 4a and 6a. They're not like terms. All right, let's look at 5x is the next one, 5x to the first power. What is like 5x? Well, 2x is like 5x. And even though this is a negative coefficient, that's okay, as long as the variable and the power is the same. So those three are like terms. All right, what about, let's change colors. Let's do, we'll do purple. All right, I have a constant of 10. Woo, it's hard to do that. What about -2? Is that a constant? Is it attached to a variable? It's not attached to a variable, so it is a constant. What else is a constant? 0, because it's not attached to a variable, right? So those three purple circles or ovals or whatever they are, they're like terms. And then finally, we have a couple of C's here. We have 7C, we have 5C, those are like terms. And then 4a squared is all alone because there is not a term that is like that one, which is fine. It's a loner, it's fine. That is all by itself down there. There's not a term that's like it. So when you have like terms, you can add or subtract the coefficients. For example, 4x is like, guys, you don't think of this as 2x, you think of it as minus 2x. So since 4x and -2x are like terms, you can combine 4 minus 2, and we get 2x. And then these are like terms. So we have a positive 2y and a positive 3y. So that's like saying 2 yo-yos plus 3 yo-yos is what? 5 yo-yos, right? And now, since x and y are unlike terms, that's as far as we can go. We can't go any farther right there. That is the answer. We have simplified it. All right, let's look at this one. What about 5x is like positive 2x? What's 5x plus 2x? 7x. And then we have some constants. We have positive 10 minus 9. What's positive 10 minus 9? Plus 1. 7x plus 1 is the answer. All right, so now it wants us, on the last problem right here, it wants us to figure out which of these is equivalent to this. Well, I am going to go, okay, well, I can do some things right now in these parentheses. I can combine these like terms. I have 4x plus 1x. I don't see a 1 there, but isn't that just 1x sitting there? It's not 0 x's. I wouldn't see any x's. It's 1. So the first thing I'm going to do is I'm going to combine like terms. I'm going to say 4x plus 1x is 5x. 2 is a constant. So even though I can't add unlike terms, you can multiply unlike terms. So now that's what I'm going to do. I'm going to use the distributive property. Since I can't add those unlike terms, I have to use the distributive property. So 3 times 5x is 15x, and 3 times 2 is 6. So which of these is equivalent? Well, the answer is A. Now, is that the only one that's equivalent? Well, A and B are definitely not equivalent, correct? So I know B is out. Well, let's see what happens when we get letter C. Let's use the distributive property. What's 3 times 4x? 3 times 4x is 12x. And 3 times 2 is 6. So C is not equivalent. Let's look at letter D. What if I use the distributive property? What's 3 times 5x? 15x. And what's 3 times 2? Positive 6. So guess what? There's two answers. The answer is A and D. They're all equivalent expressions. A and D. All right, let's look at these two problems. These are two separate problems. So the first thing I want to do is figure out, are these two terms equivalent? Well, there's two different ways we can do it. We can do it the same way we just did the last problem, where we combine like terms, use the distributive property, and see what we get. Another thing we can do is always set our exponent equal to 1 and substitute. So let's do that first. We're going to do it both ways and see if we get the same answer. All right, so if we multiply, if we make x equal 1, let's say we'd have 5 times 1 plus 2y minus x is 1. Well, 5 times 1 is 5. And 5 minus 1 is 4 plus 2y. That's what we got, okay? Let's do it, same thing here. We're gonna make x equal 1. So we're gonna say 2 times 1 plus y. So 2 times 1 is 2 plus y. Well, now the only thing we can do is use a distributive property, because these are unlike terms. So 2 times 2 is 4. And 2 times y is 2y. Well, look, we proved they're they're equivalent. They're exactly the same. Now, let's say we're not using the substitution. Let's say we're just going to do combine like terms and use the distributive property. Well, we're going to combine like terms. 5x combined with minus 1x. 5x minus 1x is 4x. And 4x plus 2y is what we get when we combine like terms. Well, right here, we're going to use the distributive property. 2 times 2x is 4x. And 2 times, how many y's? 1y. 2 times 1 is 2y. So yes, they're equivalent. All right, let's look at the last one down here. We have a couple of like terms in the parentheses, so let's combine those first. So 1z plus 6z is 7z, and then 3t has to sit by itself. All right, so now we're going to use the distributive property. What's 4 times 7z? 4 times 7z is 28z. And then 4 times 3t, what's 4 times 3? 12z. So 12t, excuse me. Are these the same? They are equivalent to each other. Okay, so that's how you're going to look at some equivalent equations this week. All right, so let me pull up. Let me share this other screen I have with you. All right, so Monday we did that. Tuesday we talked about that. Wednesday, Thursday, and Friday. Okay, so for Thursday, you're looking at equivalent expressions, which is what we just talked about, okay? We just talked about equivalent expressions. And you're gonna go through this whole module, this whole, not module, but lesson. You're gonna read, you're gonna do, there's a lot of example problems. There's a couple of videos in there. Take your time, look at it, do all of the practice problems. All right, so then when you get to page 8 of 8, it's gonna tell you you're gonna do a little project option 1. Well, I have taken this page and I have copied it. So if you'll go to next, here is that document. It says click on the link below. It will open in your Google Drive. You can type directly onto it. Follow the directions and answer the questions. You don't need to share it with me. I'll have access to it. So when you hit Module 6, Equivalent Expressions, it will pop up in your Google Drive. You can type right on it. All right, so you're gonna read the instructions. You're gonna do part A, writing expressions. I have bolded some words for you that I think are pretty important. It says you're gonna write an expression that looks like Sarah's expression, 5 times the quantity of 2j plus 3 plus j. You're going to replace the coefficients so that your expression is not equivalent. You may use any number that you choose to replace the coefficients. The coefficient is the number multiplied by your variable. Be sure to leave the variables the same, and then they give you an example. This expression looks like Sarah's expression, but it's not equivalent. Oh, I shouldn't have typed those silly letters. I was just making sure I could edit it. And then you're going to translate the algebraic expression you created in question 1 to a verbal expression, okay? For example, 8 times the quantity of 3j plus 7 plus 3j. Now you can't use that one. And then you're now going to use mathematical properties to create 2 expressions that are equivalent to the expression you created. So the properties are identity property, distributive property, commutative property, and associative property. Those are your choices. Oh, and it tells you those 2. Okay, so you're gonna be creative. Part 4, you're gonna pick a number from 1 to 10. You're gonna use that number to verify your 3 expressions, the one from part A and the one from part B. You're gonna make sure they're equivalent by substituting a number for a variable, like I just did. I'm gonna let x equal 1, and I'm gonna substitute. You have to show all your work for complete credit. And then for part 3, you're going to write a few sentences to end Sarah's story. Sarah's story was here at the beginning. Read the beginning of it. You're coming up with a little ending. How many shark teeth did she find? How many shark teeth did John find? How much money did she earn? Okay, so you're just ending her story there. Simple, simple, simple. Okay? All right, so like I said, that is in your Google Drive. You're just gonna type right on it, okay? And then the last thing you're gonna do for Friday is you're gonna go through properties of operations for advanced students, which is what you are, right? Your objectives are, I can use the properties of operations to multiply rational numbers, and I can use the properties of operations to divide rational numbers. So you're gonna go through this lesson. You're basically multiplying positive and negative numbers. Okay? And then there is, like, I think about 4 questions. You're gonna answer 4 questions on properties of operations for advanced students, okay? So you're just multiplying. You're multiplying 0.4 times negative 4.5. So when you multiply a positive times a negative, you're gonna get a negative answer. You're gonna simplify, you're gonna divide these 2 negative numbers. When you divide 2 numbers with the same sign, you get a positive. So 2 negative numbers being divided is a positive answer. Same thing, number 3, when you divide two numbers that have different signs, so positive 3/5 divided by negative 4/9 is a negative answer, And then you're gonna look at Pedro's math work and decide which step he messed up on, okay? So there's literally 4 little questions for Friday, okay? All right, guys, well, that's it for the week. And if you need me, you have any questions, just send me a message and I will get back to you. Everybody have a great day.